Hello, everybody. We're gonna do lab number 5. Um, as we can see, we need to do the following um, circuit on SIMULINK. We have already MATLAB, so we're gonna open the SIMULINK. And we're gonna start with blank instructions. As we open SIMULINK, and we can see one more time the circuit that we need to design. We're gonna need four step functions, adder, um, three power sources, AC power sources, one ground, one asynchronous machine in SI units, uh, multiplexer, and demultiplexer. We're gonna need a gain and three oscilloscope or scopes and three displays to view your data. So we go in here and we're gonna go to the library. We can start adding. So we're gonna start with the steps. So you can type here steps, or I can go by my previous research search, and I'm just gonna put one. It's gonna take a little bit of time. Then I'm just gonna go ahead and copy and paste um, for time's sake. I'm gonna start aligning it where I want what I need to be or where I want it to be. So we're gonna go with the sum. Center, we have a sum right here, so I'm just gonna put it. I'm just gonna leave it as it is. We're gonna go into details later. So we're gonna go to AC power supply or voltage source, and we're gonna have it here. So I'm just gonna drag it down. Sorry. We have it here. The same thing, copy and paste, copy and paste. We have three. I'm gonna go to ground. And I'm just gonna get the ground. And I'm gonna go to asynchronous presenter, and I'm gonna get asynchronous machine in SI units. So I'm just gonna bring it over here, type it. As you can see, it's different than the instruction that we have, but we're gonna fix this in a little bit. So now we're gonna go get the bus selector and bus creator. The bus selector is the one that increases our output from one input to two outputs, and the uh, creator is the one that does the opposite. From multiple outputs to just one, from multiple inputs to just one output. Um, then we're gonna select the scopes. As I said, we're gonna need three. So I'm just gonna go copy and paste. Display, we're gonna need three displays. And this one is okay. Oops. So we're gonna start arranging, and let's see. Do I missing something? The three scopes. Oh, we're missing the game. So we're gonna go here and game. There we go. We're done with this, and we check here. All right. So we're gonna have one input, six outputs. Sorry, eight outputs. Then we're gonna have here three inputs, one output. Three inputs, one output. Then on the oscilloscope, it's gonna be two outputs each. And there you go. The summation, we have four different step functions, so we're gonna need to add them up. As we understand, is one is the main one, and then we subtract from the other ones. So it would be one plus, and the other ones are minus or negative. As you can see right here, we have one plus and three negative. And we're gonna start connecting them. Then we're gonna go to the asynchronous. We're gonna double click, and we're gonna see rotary type. We're gonna put it as a squirrel cage. Apply, and now we have our design that we needed. We're gonna go to the power supplies. We're just gonna adjust it. We see we're gonna title BA, BA, BB, and BC. So we're just gonna click right here, BA, BB. Fine, however you want to title, but it will help you to understand better. Our ground. This is the convenience of naming it this way, that we're gonna connect each power supply or power source to one of the faces of the asynchronous machine. We're just gonna leave here. Now we're gonna go to the buzzer. As I told you guys, we're gonna need to have six input. Sorry, six plus two is eight. So we're gonna remove this one. But first of all, we're gonna connect them because it's based on the input of this one. So we're gonna double click, and we're gonna go mechanical. We're gonna need the rotor speed. Select. Sorry, we're gonna need to eliminate these two. We're gonna select rotor speed and the torque. Then on the starter measurements, we're gonna need the current for A, current for B, and current for C. Then for the rotor measurement, we're gonna need the rotor current for A, rotor current for B, rotor current for C. Okay, this is very important. As you can see right here, I have the mechanical electromagnetic torque in the bottom, and I want to have it next to mechanical rotor. So I'm just gonna move it up, and then I will make sure that all of them are the same, or at least together. It will make um the other step simpler. So I'm just gonna apply. I'm gonna go. So as you can see, all the outputs are right there. So I'm just gonna make it more aesthetical, and I just so we have 8 different outputs, and this is the party. We're gonna need 2 buzzers, but these buzzers, oh, we need to add another signal. So we're just gonna put 3 signals each. Apply. If you can see, it looks weird. So I'm just gonna extend it, copy and paste, move it. And we're gonna connect them. Now we're gonna go with the scope right here. And this scope, we're gonna need 2 inputs. As we can see the scope right here, we're gonna go to settings, select 2 inputs, and the layout, we're gonna need a layout of 1 column, 2 rows. Apply, and then the time, we're gonna display show access on all of them. Show legends. So as I was saying, we need 2 inputs, the layout, the columns, apply, and we have right here the 2 graphs. They're similar. So we're just gonna close this, and we're gonna connect the output from the buffer, and we're gonna name it. And this one is rotor and starter. Starter currents. The gate right here. So the gain right here, we're gonna put it 60 divided by 2 times 5. Remember, because this is MATLAB function, we just put pi and identify as apply them. And we're gonna connect these two. We're gonna make this scope the same way that we did the other one. We're gonna put 2 inputs, the layout. We're gonna go to display, time, and time access label in all of them, just for reference. Now we have it. Now we're gonna connect it, and we're gonna connect the output. So this will be the rotor speed, because the rotor speed is so small. We're gonna amplify it and connect it. Now we're just gonna adjust, adjust, and now the displays. Why are we doing these displays? Just to see what is the value while the moment of that we're running it. Is for reference, and you will see it. Then we're gonna name this one for preference, rotor speed and torque. Just like to have some symmetry if possible. Now this oscilloscope and this display is going to be connected to our addition. But this addition will get connected right here. And that's basically the setup. Now we just need to go into the voltage area right here and the step function. So first of all, we're gonna go into the voltage. The voltage is gonna be based on class. We have the voltage max is equal to square root of 2 times VRMS and divided by 3. In this case, voltage max, it would be the square root of the voltage RMS value, that is 400, and then divided by 3. So we have 326.54. So because it's a three-phase, we're gonna have the amplitude is 326.54, but because it's an angle, we're gonna have it at negative 120. The frequency, we can put it 60 or 50. We're gonna go with 50. The voltage on B, it would be the same voltage, 326.54, but the phase angle or the phase degree is gonna be equal to 0. And now we go to C. We're gonna go have in 326.54, but this angle is gonna be 120. You see the apply. A is a negative and C is a positive. So that will define the three different angles. Now, the step function. We're gonna have uh, the step function are gonna come in at different times. The first one is gonna be at t equals 3 seconds. The second one at 5 seconds. The third one at t equals 10 seconds. And then the fourth one is equals to t equals 13 seconds. So how do we calculate the value of the step function? We're gonna go into our calculations. And as we can see, we're gonna have some setup parameters. Like the PL has to be 400 watts, and our RPMs has to be 1,430 RPMs. So we're gonna plug in that into this equation to get our angular velocity, and this one it will be 149.67. So out of this one we can calculate the TSH. They will be the force of the motor, and it will be 4,000. That is the power output divided by the angular velocity, and this one will provide us with a force, initial force. This initial force, as you can see right here, it will be the one that we're gonna input on the first one. So this value is the force at t equals 3. This the second one is going to be divided by at t equals 5 is going to be divided by 2, and at t equals 3 is going to be divided by 4. By the last step function that is t equals 13, we should have equals to 0. So we're going to go to the program, and we're going to put it here. Time setup is at 3 seconds, the first one, and the final value is going to be 26.72. Right? The second one is going to be at 5 seconds, and it's going to be equals to 26.72 divided by 2, or we calculate at 3.36. So what it does is this is our first value, 26.72, And then because we adding a negative, we're gonna subtract this value, and it's gonna give us uh, a different value. And then when time is equal to 10, we're gonna have 26, 26.72 divided by 4. In this case, is 6.68. In the same way, after at the beginning we have this value that it was 26.72, then we subtract 13.36, and now whatever value we have after these two, we're gonna subtract 6.68, and then on t equals 13, we're gonna subtract the last, they will be 6.68 to make the signal become 0, and we're gonna see it in a little bit right here. Um, so these are the parameters given. Uh, in addition, as we can see, the RPMs are very fundamental in this equation to find the angular velocity. And if you see in the K on the gain right here, we multiply it. Can I make it bigger? We invert this to compensate for that one because we want to see the speed of the angular velocity. So we're going to compensate it right here. Um, then the other thing is like our time is going to be more than the total time right here. And we're going to run with 15 seconds and step back. What we're going to do is just put 5 step backs. Just we want to see a beginning before or more information. Then totally forgot. We need to put power with the power library into our system, and we have it. Now we just need to run it. This at the beginning it takes a little bit to compile it and run it. The second, third time, or and thereafter is faster. As you can see, the time is moving. We can see that there's a movement. To adjust the graph, we're gonna go here in multiple, and we're just gonna click on it and see how it's moving. But we're gonna have 3 different graphs. So as you can see the graph right here, we're gonna have the 3 graphs. The first one is gonna give us this step response. So it will be 0 at time equals 3. We're gonna have a value that is 26.72. Then it's gonna decrease by the third value that was inserted right here at t equals 5. They is equal to 13.36. So out of 26.72, we're gonna deduct 13.36, and it's gonna provide us a value of around the same 13.36. Then we're gonna deduct 6.68, that is right here, from this value, and we're gonna end it up in 6.68. And then on the last one, this one is gonna deduct the last 6.68 to make it 0 again. On the torque and on the rotor speed and torque, we're gonna have the reference at the beginning. We have this sharp this high speed, a small torque. Then until it's because it's the motor is starting. Then we it's gonna level up or stabilize to get to a steady rate, and we're gonna have um, a regular speed and regular torque, and then we're gonna have the chain at 3 seconds. That is gonna decrease our speed, but it's gonna increase our torque because it's 26, as you can see it on the step function right here. So after that, it's gonna decrease, as you can see right here. Our torque is decreased from the previous one, and our speed has increased a little bit. On the if you see right here, it's negative, but actually it's increasing our speed, um, decreasing our torque. And the same goes for the next one, increases our speed, but decreases our torque, and so on until the 13. Uh, Now we're gonna have the frequency. As you can see, we have like the current is color coded. Is all of them are right there, but as you can see, we have the starter of the motor. That is the most messy. Then stabilize, like right here, and then we have the time equals 3. We're gonna have a reference of the current. The in this case is the less current on the rotor, just to display. Um, I'm just trying to look for. So as we can see, we have the t equals 3 seconds. We're gonna have difference right here, and we're gonna have the chain and pattern. I'm not aware. This one is the rotor, and this one is the starter. As we can see right here, we have from t equals 3 seconds to 5, one frequency, the same as one value, sorry, and a frequency, the same happen here. And then it happens from 5 to 10, the same way. And you can see the peaks are changing. So it makes it a little bit clear. But then from 10 to 13, we have another one, and you can see right here, this one is very small changes because the amount that is changing is little. But then you see it right here, they goes from the lowest to the to 0 on the step function, and we can maximize it if you want to see it. And you can see how it's changing. But basically, just want to see this, and yes, this is the setup, and that will conclude our demonstration.